All right, this is one of my favorite lessons. So we're doing Unit 10, Rational Functions. So day one, we're going to simplify, multiply, and divide rational functions. So the first thing you need to know about rational expressions is it really just means I'm dividing polynomials. The big idea of what we're doing today is that your numerator, the top of the fraction, and the denominator, the bottom of the fraction, we don't want them to have anything left in common. So just by showing this little idea over here, so if I have a times b on top, and if I have b times c on bottom, since there's b on both top and bottom, I go ahead and cancel them out, and I'm just left with a over c. So to be able to see what the numerator and denominator have in common, everything must be factored. The last thing I want you to keep in mind today is that if you type 3 divided by 0 into your calculator, the calculator is going to give you an error. If you have x divided by 0, that's also an error. So remember, anything divided by 0 is undefined. You can't divide by 0. So in the simplifying, we're going to do something called finding the domain. And we're going to pick out what x values would make our denominator 0. So here are two examples. The first one is already factored for us. I have x plus 2 over x plus 3 all over x minus 1 times x plus 3. So remember the first thing I said, keep in mind your denominator can't be 0. So I have to look and I have to say, okay, what will make x minus 1 equal 0? So I know that if x was 1, my denominator would equal 0. And I do the same thing with x plus 3. What x value would make x plus 3 equal 0? And that's 3. So the first thing I'm going to do is say, okay, my domain for this is that x could be any number except for 1 and 3. Oh, and negative 3. Whoops. So just stating the domain, that's all you have to say about it, is x cannot be 1 or negative 3, because that would give me a divide by 0. So then from here, I have to look and see what multiples or what factors repeat in top and bottom. X plus 3 occurs in top and bottom, so those will cancel out, and my final answer is x plus 2 all over x minus 1. In the second example, I have a polynomial on top and a polynomial on bottom, and neither of them are factored, so we're going to have to factor both the top and bottom. If you know shortcuts or there's faster ways to do that, you can do that. Otherwise, you're going to have to use the star method on the top and the bottom. So I need to find two numbers that will multiply to negative 3 but add to negative 2. And my two numbers there will be negative 3 and 1. So on the top, that's going to factor out to be x minus 3 and x plus 1. On the bottom, if I do the star method, I would get x minus 3 and x plus 2. Those are my two numbers that would multiply to negative 6 but add to negative 1. From this point, we find our domain. So I need to know what number, if I put in x minus 3, would give me 0, and I know that would be positive 3. To make x plus 2 0, if I put negative 2 in for x, that would give me 0. So from here I just look, I have an x minus 3 on top and bottom, so those cancel out, and my final answer is x plus 1 all over x plus 2. Examples 3 and 4 are examples of multiplying two rational expressions and dividing two rational expressions. This really follows the exact same steps you've seen before. Factor everything, find the domain, and then cancel. So to factor this first example, the first thing I notice is that it's not in standard form. So I'm going to reorder it so that it's in standard form. From here, I'm just going to look for GCF because there's only two terms. Negative 3x squared and 3x, they have a negative 3x in common. So I am left with x minus 1. On the bottom, x squared plus 4x minus 5, I need two numbers that will multiply to negative 5 but add to 4. So that gives me x plus 5 and x minus 1. On the other side, I have x squared plus x minus 20. My two numbers that would multiply to negative 20 but add to 1 would be x plus 5 and x minus 4. And then on the bottom, I just have a 3x. So I'm going to write this out a little bit cleaner once I have everything factored. So I have negative 3x, x minus 1, all over x plus 5, x minus 1. And I'm multiplying it to x plus 5, x minus 4, all over 3x. So when I go to state my domain, I have 3 x's on the bottom, which means I have 3 values that x cannot equal. For this x plus 5, if I put a negative 5 in for x, that would give me 0. For x minus 1, if I put a positive 1 in, that would be 0. And for 3 times x, 3 times 0 would give me 0. So my domain is that x cannot equal negative 5, 1, or 0 for this problem. Now I can cancel out what I have in common, so the x plus 5s will go, the x minus 1s will go, and I also see I have a negative 3x on top and a positive 3x on bottom. So the 3x's will actually leave and leave me with a negative 1. So I have negative 1, x minus 4 are my only things left. I can either keep it that way, or you can distribute the negative 1 in to get x plus 4. Either answer would be acceptable. This division problem, I want to say it's just as easy. There's just a little bit more work to it. So I'm going to do the exact same thing though. I'm going to factor everything and then state my domains. So for this top problem, I'm going to fill out the star for this one. I need negative 90 on top and 1 on the bottom. My two numbers that multiply to negative 90 but add to 1 is going to be 10 and negative 9. 10 over 6 will simplify down to 3 over 5. And 6 over negative 9 will simplify down to 2 and negative 3. So the top factors out to 3x plus 5 and 2x minus 3. 4x squared won't be able to factor, so I can go ahead and write that. Over here, the 3x squared plus 5x. The only thing I can do there is they have a greatest common factor of x. So I'm left with 3x plus 5. And the bottom two, that will not be able to factor. So I can just write this out. All right, when I go to state my domain this time, I have to do it a couple times. So I can say that x cannot equal 4x squared. The only number that I would put in there that would make it 0 would be 0. And 2, there's no way to make 2 0. 2 is 2. You guys might hopefully remember from like middle school or years past how you divide fractions. Dividing fractions is the same as multiplying by the reciprocal. So that's actually what I'm going to do. So I'm going to rewrite this problem. I'm going to keep the first fraction the way it is. I'm going to change this division sign to a multiplication sign, and I'm actually going to flip the second fraction. So I don't know if some of your middle school teachers or teachers you've had before has explained keep, change, flip. So now that I flipped it, you notice I have a new denominator. So that means I have to go back to my domain and say, okay, what else would make this denominator 0? This x out front, the only thing that would make it 0 is if it was 0, and I already have 0 in my domain. 3x plus 5, this one's a little trickier, so I'm going to set it equal to 0. By solving for x, that will tell me what x value will give me an answer of 0. So it's 3x equals negative 5. If I divide by 3, I'm left with x equals negative 5/3. So my domain values is x could not be 0 and x cannot be negative 5/3. Now that I finally found all of my domain values, I can go ahead and cancel anything that appears on top and on bottom. So 3x plus 5 shows up in both areas. So I'm going to bring this 2 out front, so I have 2, parentheses, 2x minus 3, all over 4x squared, and then x. So the first thing I notice, I actually have 2 divided by 4. Well, that's something I can do. 2 divided by 4 is actually just 1 over 2. So that's 2x minus 3 all over 2. And here I'm multiplying x squared times x. So that will actually simplify down to 2x to the 3rd power. So there you have it. Here is just steps to simplifying rational functions. I know a lot of you work better when you're given step-by-step directions. So step number 1 is always going to be factor your numerator and denominator. Step number 2 is going to be state the domain. So remember, that's just looking at the denominator, which x values will give you an answer of 0. And then the one thing you do have to remember, if it's a division problem, that's where you need to flip the second rational and then find the domain of the new denominator. Step 3 for every single problem is cancel any factors that appear on top and bottom. And step 4 is just rewrite it where there is nothing left to match. So these are your try your own problems. So you just have 4 examples, or 4 try on your owns that go along with the 4 examples. Remember, you need to get these done before class because some of you are going to be called to do this on the board. Good luck.